B8 sum trig, short for trigonometry, identities. Here we have a plot of the cosine of x, and here is the sine of x and x. And you can see that when the x is 0, the cosine is 1. And then it is a cycle, see? And the sine of x crosses the y-axis at 0. But what I want to show you here is that the cosine function is an even function. That means if you go to the right or the left, you get the same value if you go the same distance out. It's like a mirror reflection symmetry. While here, you have to reflect and turn it upside down. So in other words, here if you're at the right-hand side, say at this point, if you go to the left side, that distance, it's negative. So in other words, the cosine of minus x is equal to the cosine of x. It's very important that we remember that. And the sine of negative x is negative the sine of x. These are very important. Then the other formula is very, very famous formula that if you take the cosine squared of an angle x, or say theta, and you add it to the sine squared of theta, you get 1. And that follows from the definition we gave you earlier, that if you have a hypotenuse of 1 and you have here an angle theta, that the cosine is the adjacent side and the side that's opposite is the sine. And the Pythagorean theorem would say cosine squared plus sine squared would be the hypotenuse squared, 1 squared. Now for our next identity, we're going to draw a rectangle. Then what we're going to do is we're going to draw from this lower corner, we're going to draw a hypotenuse up, and then we're going to go perpendicular here, a right angle, wherever that takes us, up to here. Now we're going to call this angle here alpha. Now I'm going to connect these 2 points here. And I'm going to call this angle beta. This one in here, beta. This is a right angle there, right angle here, right angle there, and right angle on the left and also on the right side. Now this angle here we're not really going to need, but I'll go ahead and put it, say a gamma here. There's a gamma angle there. Now notice that gamma and alpha equal 90, since a triangle has 90 plus 90 has, in other words, a triangle has 180 degrees. So that means the alpha and the gamma are complementary. But since a straight line has 180 and you're taking up 90 here, that means the other angle up there has to also equal alpha. So alpha is here and alpha is there. Now since the alpha and the gamma gives you 90, and that's a right angle there. This has to be also up there. But we're going to focus on alpha and beta. This has to be gamma. This has to be gamma up there. Okay, now let's look at this long line, and let's assign that to have length 1. That's length 1. What can we say about this angle in here? Well, if you look at this Z, and from geometry, when you have a Z, the alternating interior angles are the same, which means this has to be alpha plus beta. I like to think of this as the Zorro, or Zorro rule, the Z. You make the Z, then these angles are the same. So here's our Z, and then alpha plus beta. This has to be alpha plus beta. Alpha plus beta here. Need to have an alpha plus beta up there. The Z, Zorro, or El Zorro. Okay, now here we have some interesting things going on. If this is 1, then the cosine of beta is the adjacent side, and the opposite side is sine of beta. But now this is the hypotenuse for this triangle. So this adjacent side here is going to be equal to the hypotenuse times the cosine of alpha. I'll write the cosine of alpha first, and the cosine of beta. So remember the rule, if you have the 1 for the hypotenuse, like in this triangle, then the adjacent side is just cosine of the angle, beta, and the opposite side just sine of beta. But if you have an hypotenuse that's not 1, then you have to multiply the cosine by the hypotenuse, like scaling it, in other words. Scaling it up or scaling it down. In this case, we're scaling it down. All right, now if we look at this side over here, this would be the cosine of beta times the sine of alpha. I'll put the sine of alpha first. Sine of alpha, cosine of beta. That's this piece here. All right, we can emphasize it by doing this and doing that. Then over here, this would be the adjacent side of alpha, and here's your hypotenuse, sine of beta. So this is the sine of beta times the cosine of alpha. I'll write the cosine first. Cosine alpha times sine of beta. And that gets us this length. Now we're going to look at this triangle and this angle in here. Now the opposite side for this angle is this one, and you have a right angle here. It's a right triangle, and this is your hypotenuse. So that means for the opposite side, this has to be the sine of alpha plus beta, this whole length. So now we have a nice formula that looks a little scary, and that is this whole length here is add up these two lengths, since that's a rectangle. This side and that side are equal. So that means when you add these two together, you'll get the sine of alpha plus beta. That's the sine of the sum, alpha plus beta. That has to equal cosine of alpha. Just going to add these two pieces. Sine beta plus sine alpha cosine beta. So that's one of our trigonometric identities. See, that's a neat one. A little complicated there, but you can see from the figure where it comes from. This one people don't really memorize. I wouldn't worry about that one. So the other one, though, is what about the cosine? What about the cosine of alpha plus beta? Well, the cosine of alpha plus beta, well, that would be equal to the adjacent side, which is this one here. So this is the cosine of alpha plus beta, is this piece right here. Now what about this little piece in here? Well, if you take the hypotenuse, the sine of beta, and this is opposite the alpha one, this is sine of beta, sine of alpha. I'll put the alpha one first. Sine of alpha, sine beta. So to get the cosine of the sum angle, you're going to take this big one down here and subtract this piece here. So the big one down here is cosine alpha, cosine beta, and we're going to subtract this piece here, sine alpha, sine beta. It's kind of a neat formula, cosine of each angle, sine of each angle. Now the last thing to do here is define the identity for the difference, alpha minus beta. And now we're going to use the even and odd functions here. Here, alpha didn't change, so that's cosine of alpha. But now the beta becomes negative, but the cosine doesn't care, because the cosine is the even function. So we simply write down cosine beta again. And now here, the sine will care. So now we didn't change the alpha, so we have the sine of alpha is going to be here. But the minus beta in there is going to flip the sign there and make this a plus sign. So this is going to be the trigonometric identity for the difference. And then with the cosine, but what about the sine? One last formula here. It would take the sine of alpha minus beta. We're not changing the alpha, so this is cosine of alpha. And when we go with the negative beta, this will actually flip because the sign is odd. Now over here, the sign's not going to change and the cosine's not going to change because cosine's even. So what people like to do in this case is they like to rewrite this so that the plus one is first. So they write this one first, the sine of alpha, cosine beta, and then minus here the cosine of alpha and the sine of beta. And don't memorize these. These are kind of like mind-boggling to keep them straight. But you know where they come from. We do derive everything in this course. See, in algebra and trigonometry, the formulas that we're going to be needing. Well, we're not quite finished here with the trig identities. There's one here that's really cool, and that is to take alpha equal to beta. And then you have the sign here. Let's say alpha equal beta. Let's take the case alpha equal beta equal theta. So we'll write this then as, this is going to be then the sine of 2 theta, because each one of these is a theta. All right, that's going to equal. So here, if alpha and beta are thetas, they're essentially the same, then you're going to have a cosine theta times a sine theta, and another sine theta cosine theta. So you're going to get 2 of them. And you get 2. I'll write the sine first, sine theta, cosine theta. That's another trigonometric identity. That's very, very handy. And then the final one would be the one that comes from the cosine. So the cosine of 2 theta, because remember this is theta and this is theta, so there's two thetas there. That's going to be, well, theta and theta, that's going to be a cosine squared theta minus a sine squared theta. Cool formulas. Very, very nice formulas. Now, a variation of this formula that you sometimes see, you have cosine of the 2 theta, you have the cosine squared. What you find is that if you replace the sine squared with 1 minus the cosine squared theta, because always remember that the cosine squared theta plus the sine squared theta is equal to 1. You have your 1 for your hypotenuse, and you have a theta here. This is your cosine, the adjacent, and your opposite, your sine. If you square these and add the squares, then you get 1 squared, which is 1. So that means the sine squared is 1 minus cosine squared. So when you do this, you get another identity. You get cosine squared theta minus 1 plus cosine squared theta, because the minus signs give you the plus sign. And then here we see that we got 2 cosine squares. So we have then cosine of 2 theta equals 2 cosine squared theta minus 1. And you could write that as 2 cosine squared theta equals, bring the 1 on the other side, and 1 plus cosine 2 theta. And another identity is the cosine squared theta is 1 plus cosine 2 theta, all divided by 2. And now we can replace this as 1 minus the sine squared theta. We're just deriving trig identities in this section. Right? Can be useful. So we have this. Now this gives us minus sine squared theta equals 1 plus cosine 2 theta over 2 minus 1 by taking the 1 on the other side of the equation. And if you have a 1/2 and a minus 1, you'll have a negative 1/2. So this is sine squared theta. It's going to be equal. This is 1/2 minus 1 is going to be negative 1/2. And then we'll still have the plus cosine of 2 theta over 2. And then if we multiply through by minus, we'll get sine squared theta is equal to 1. And I'm going to put the 2 as a common denominator here, like that. So let's look at this. Sine squared equals 1/2. So sine squared, you multiply through by minus 1 is 1/2. And then it's going to be minus the cosine of the 2 theta quantity over 2. And that's what we have here. And you will find in the notes these things worked out, and also a nice summary here of all the identities that we have derived. We're going to need most of those, or a lot of those will show up. We'll counter a lot of those.